Okay, 7 is talking about an arithmetic progression for the first bit and geometric for the second part. So look at the formula sheet right at the beginning and I'll paste it in here so I can now see what I need to do. Right, so I've got first part A. First term is AP, so I might as well write that down. First term A is 12. S70 equals 12915. That means that n, the first 70 terms, is 70, and we've got to find what d equals. So basically I'm just going to substitute into there. So we know what n is, we know what a is, we know what n is. That means we can find out what we need to find the d. So just put that into a formula. So sum 12915 equals half times by n, which is 70, and then we have brackets 2 times a, which is 12, plus n minus 1, so it's 70 minus 1 times by d. So that's 35. So if I put it around the other way around, that'll give me 24. That's that bit, plus 69d equals 12915 divided by 35. That's 35 here. Divide both sides by it. And that says that 69d equals, do it on the calculator, that gives me 369. Take away 24. 69d equals 345. So d equals, divided by 69, that's 5. And that's the answer for the first part. Now for the second part, I'm going to do it over here because I need a little bit more room for this one. 7 marks, this probably should take me a bit more. So what's this going to be? It's a geometric progression, so I'm going to put down GP. Second term, if used n's 2, we get a times by r to the power n, so r to the power of 1. So that'll be, I know that r will be negative 4. Sum to infinity, so sum to infinity equals 9. So that gives me from here. So I get 9 equals that, which is a over 1 minus r, and I've got ar equals negative 4. And then basically I've got 2 equations to find. I want to find out what r is, so I just have to work it out. So I work out what a is here, times both sides by 1 minus r. So a is 9 times 1 minus r. So a equals 9 minus 9r. And I'm going to substitute that into here to give me 9 minus 9r, that's the a, times by r equals negative 4. Multiply that out, 9r minus 9r squared equals negative 4. And I'm going to add that to both sides, take away that from both sides, and that's going to end up giving me that 9r squared minus 9r minus 4 equals 0. I'm going to factorise that, I hope. If I don't, I'll use the formula. That equals 0. Let's get 9r squared. It's going to have r and r. I think it's going to be 3r and 3r. And I've got to get 4, so the only way to get 4 is 2 and 2. If I have 2 and one's positive, one's negative, it won't be 2 and 2. It's going to have to be 4 and 1, so I'll put them in there. One's going to be positive and one's going to be negative because it's minus 4. I want to be minus 12, so that's going to be minus there, and that's going to be plus. Just check. 9r squared minus 12r plus 3r is minus 9r minus 4. That's great. So either 3r plus 1 equals 0 or 3r minus 4 equals 0. And so 3r equals negative 1. So r equals negative 1/3, or 3r equals 4, r equals 1 1/3. So those are our 2 possible answers, but the sum to infinity exists, and that's only true if the modulus of r is less than 1. So it can't be that one. It has to be r equals minus 1/3, because sum to infinity exists. Therefore, the modulus of r is less than 1, i.e. that it goes between -1 and +1. And that's 7 done.